Hello everyone, welcome to today's class. We'll be starting with the differentiation. Next topic is chain rule. So let's begin. Okay. So basically, when do we apply a chain rule? Okay. So suppose you have a function of function or function inside a function. For say, let's take one simple example. You have to differentiate sine x square dash. Okay. Now how do we do this? Basically, we'll show some steps first of all, and then we'll come to the direct conclusion of it. So basically, meaning is dy dx of sine x square. Okay. Now how do we do this? We cannot differentiate sine x square with respect to x directly. The idea is that the d by dx of sine x is cos x. Means if only x was present, then only the differentiation was cos x. However, if we change that differentiation of sine x square with respect to x square, means dx square, that will be cos x square. Means if this variable matches with this, then the differentiation we can directly do, otherwise we cannot. Same thing here also, dx sine x square is there, dx square is there. That means we can do direct differentiation, that is cos x square. So for this it doesn't work. So what we do is we try to generate a new variable accordingly. First of all, this x square, okay, let it be z. Let this be z. So your question will look like d by dx of sine z. Okay. Now multiply by dz by dz and interchange the position of these two. So what do we get? D by dz of sine z into dz by dx. Now directly we can solve this one. Okay, this one we can solve. Dz by d by dz of sine z is cos z. Okay. Cos z, and in multiplication what do we get? Dz by dx. Let's replace the value of z. Okay, what was z? X square. So cos x square into d by dx of x square. So we get cos x square into 2x. So basically 2x cos x square. Okay. Now these steps, like multiplying, this was z. Okay. Multiplying dz by dz, then interchanging them, then we get this. We'll just skip these steps directly now, from now onwards. Okay. So how do we conclude this? How can we skip these steps? Basically, first of all, you do is check whatever is your first function, leave that, and the second function inside it, or the third one, or whatever, how many functions are there, take that as z. Okay, and then differentiate with respect to x. Whenever differentiation is with respect to x and the variable is instead of x, it is some z, you get dz by dx in multiplication. Okay, whenever we differentiate sine z with respect to x, we get another factor in multiplication, that's dz by dx. Okay, let me clarify this with one more example and the direct conclusion accordingly. Let's say we have to do the differentiation of sine bracket sine x. So inside sine there is another sine x, and you have to differentiate this. Okay, so first function, whatever is the first function, leave it. Whatever is present inside, consider that to be your z. Okay. Now differentiation of this. Now basically the question will look like this: sine z differentiation. What is differentiation of sine z? Directly say it's cos z, and just say that dz by dx will be additionally present here. Okay, so cos bracket sin x and differentiation of or dy dx of sin x. Okay. So cos bracket sin x into cos x. Okay. The reason I'm doing this fundamentally because if you have any confusion with chain rule ever, it will be clarified with these steps. Whatever is the first function, leave it, and remaining thing, whatever remaining thing is, it can be a single function, it can be multiple functions, consider that to be your z. Differentiate normally, sin z differentiation is cos z, just add additional factor of dz by dx. Okay. Okay, now let's look at few questions. We'll be practicing chain rule a lot as such. Okay, same idea. You have to differentiate with respect to x. So whatever, leave the first function, that is sine, consider this to be your z. The question will look like sine z, and you have to differentiate. What is differentiation of sine z? Cos z into dz by dx can be written as z dash also. Okay, so basically cos of z was x square plus 5 and differentiation of x square plus 5. So basically that will become 2x. So 2x cos x square plus 5. Okay. That was your first question. Second one, cos bracket sin x. I just explained these kinds of questions. Again, leave the first function. The second function needs to be taken as z. So cos z, cos z differentiation. So that will become minus sin z into z dash. So minus sin z was sin x itself, and differentiation of sin x is, okay, I'm writing one step here, sin x differentiation. So minus sin bracket sin x into sin x differentiation is cos x. Okay. Same thing with the third one. Inside sine, there is no x, a complicated function is there. Whatever is that, take this as z. So differentiation of sin z, and now I directly say cos z means cos ax plus b into z dash means differentiation of ax plus b. What is the differentiation of ax plus b? B is constant, so differentiation becomes 0. Differentiation of ax is a only. So a cos ax plus b. Okay. All right. So far simple enough. Let's complicate things a little bit. Okay. Sec bracket tan bracket root x. Leave the first function, whatever is present inside, consider that to be your z, and start differentiation. Sec z differentiation. What is differentiation of sec z? It is sec z tan z into z dash additional. Okay. So sec z, replace z now. That was tan bracket root x. So tan root x basically. Tan z means tan bracket tan root z. And what is our z? Z is tan root x. Tan root x differentiation. Okay. So this is pretty much done. All we have to do is differentiate tan root x. Again, you see inside tan, another function is there, that is root x. It's not x, it's root x. So again you have to apply the chain rule here. Consider that to be your new z. Okay, new z. Okay, copy this. Okay, and the differentiation of tan z is sec square z, that is root x, into z dash, that is root x differentiation. So into sec square root x. What is the differentiation of root x? I'll show it one time, then I'll ask you to learn this differentiation root, because square root you have to differentiate a lot of time. So root x is basically x raised to power 1 by 2. So the differentiation is power 1 by 2 comes down, x raised to power 1 by 2 minus 1. So 1 by 2 x raised to power minus 1 by 2. 1 minus 1 by 2 means 1 upon. So 1 by 2 x raised to power 1 by 2. That is 1 by 2 root x. So you don't have to go through these steps every time, just learn it, that root x differentiation is 1 by 2 root x. Okay, you'll be doing this a lot, so don't waste time in this. 1 by 2 root x. Okay, that was your fourth question. So it's not like chain rule is applied only once. Chain rule can be applied multiple times also. All right, next fifth question is sine ax plus b cos cx plus t. Sine ax plus b cos cx plus t. I think we just did sine ax plus b, no? Cos ax plus b. A came out. The differentiation was sine of sine was cos, and a factor of a came out. So again I want to give you a direct conclusion. Like suppose your differentiation of fx is gx, then differentiation of f of ax plus b is g of ax plus b. It's just that factor of a comes in multiplication. Okay, what does that mean? See, this is the representation in function. I'll give you the conclusion part with the help of examples. Like suppose sine 3x plus 5 differentiation is asked. You know what is the differentiation of sine? That's cos. So directly write down cos 3x plus 5, and whatever is the coefficient of x, that will come in multiplication. That's it. So don't waste time in differentiation by chain rule for these kinds of function if only x is being replaced with ax plus b. Remember that the coefficient of a will come in multiplication, and this kind of rule comes in integration also. In there we'll talk about whatever is the integration of this factor, na, a factor. Right now it is coming in multiplication, there it will come in division. Okay, so remember the differentiation is same, it's just that coefficient of a x comes out. Suppose you are supposed to differentiate 2x plus 5 power 3. Okay, so pretty much it is looking like x raised to power 3, but instead of x you have 2x plus 5. So what is differentiation of x raised to power 3? 3x square. So 3, this thing is your new x, so 2x plus 5 whole square. Power comes down, one power become less, and additional factor of coefficient of x, that a is coming out. So basically 6 2x plus 5 whole square is the differentiation. The purpose of discussion of these is because I don't want to go through the chain rule. I can directly do this. This is just a one-step question. Okay, so differentiate this. So basically it's u by v. Okay, so that's cos cx plus d square v square. Numerator is u dash v minus v dash u dash. So sine ax plus b differentiation becomes cos ax plus b, and the factor of x comes out. Okay, v as it is, so cos cx plus d as it is, minus this time differentiation of cos cx plus d. Differentiation of cos is minus, so that minus will become plus. Okay. Sine cx plus d, the coefficient of x comes out, and sine x plus v as it is, u dash v minus v dash u. And that's it. We cannot solve this any further because the coefficients are also a and c, so we cannot do anything about this. Okay, but remember this concept. The reason I'm discussing this question is because of this concept. That's it. Sixth one was cos x cube sine square. So first I'll teach you how to differentiate sine square cos square. Let's take one illustration. Differentiation of sine square x. Okay, let's take sine cube instead. Okay, sine cube x. So if you rewrite this, it will look like sine x whole cube, and then you have to differentiate. Now I told you to leave the first function as it is. What is the first thing that comes? The first thing that comes is the bracket of this cube. That means whatever is present inside, that will be my z. So I have to consider this to be my z. So the question will now look like z cube differentiation. What is the differentiation of z cube? 3z square into z dash additionally. Okay, so basically 3 sine square x, and differentiation of sine x, z is sine x, no? So differentiation of sine x is cos x. Okay, now let's look at the questions. Cos x cube sine square x raised to power 5. Okay, cos x cube sine square x raised to power 5. Okay, the first thing that I see is multiplication of two functions uv. So let's first break down the differentiation. So it becomes differentiation of cos x cube sine square x raised to power 5 as it is, plus differentiation of sine square x raised to power 5 cos x cube as it is. Okay, u dash v plus v dash u. Differentiation of this will require, first function is cos, leave it, whatever is inside, consider this to be my z. So what is the differentiation of cos z? Minus sine z into differentiation of z, z dash basically. So differentiation of x cube is 3x square, and sine square x raised to power 5 plus differentiation of sine square x raised to power 5. Okay, so I'll suggest that you write it like this: sine x raised to power 5, then write down whole square. Otherwise you'll not be able to see the thing that you have to take as z. Okay, and then it's the power is 2. Okay, and cos cube x cube as it is. Now consider this to be square, na? So first thing comes is the bracket of square. So whatever is present inside is taken as new z. So this is looking like z square differentiation. Okay, copy everything else. Z square differentiation is 2z into z dash. That means 2 into, what was my z? Sine x raised to power 5. Sine x raised to power 5. And now I have to differentiate sine x raised to power 5 again, z dash, na? Into cos x cube, of course, is there. Okay. Cos x cube is there, cos x cube is there, cos x cube is there. Copy everything else. Okay, let's focus on this part. So 2 sine x raised to power 5. Now how can we differentiate sine x raised to power 5? Now this is simple. Whatever is present inside, consider that to be your z. Okay, new z actually. So differentiation of sine is, sine z will be cos z. So that means cos x raised to power 5, and then difference additionally z dash, that means differentiation of x raised to power 5, that's 5x raised to power 4 cos x cube. Okay, all right. Now that we have done few questions, I'll give you one direct method so that you can write differentiation in one single step. But remember, if you get confused, these are the fundamentals that will help you to do any question properly. If you are comfortable enough, then do go for the direct approach, otherwise go for the basics. Okay, like I had to differentiate sine x raised to power 5 and then differentiation of square. I'll start from outside. What is that thing? Square. Okay, so consider everything else to be x or z, whatever you want to do. So differentiation of square is 2 into, if it was x, then 2x, or it is right now x raised to power 5, so sine x raised to power 5. Then again come inside. Second time you see sine. What is the differentiation of sine? Cos and x raised to power 5. Then again come inside. What is the next? X raised to power 5. What is the differentiation? 5x raised to power 4. Okay. This way you can directly write differentiation. Start from outside. Whatever is outside, do the differentiation of that, copy everything else as it is, but it has a limitation that you have to understand why I've written 2 sine x raised to power 5, not 2x. Okay. For that, these are the fundamentals. Okay, I'll try to give you this approach for other questions also, so that you get some idea. Sine this is done. Okay, next question is square root. I told you to learn that. Okay, next question is having square roots a lot. 7th question, you have to differentiate this. So first thing comes 2 is constant, so leave it. Then square root comes. Okay, so whatever is inside the square root, consider that to be your z. So your question is looking like 2 root z differentiation. Constant doesn't affect anything. Okay, so 2, what is the differentiation of root x? I told you to learn it. 1 by 2 root x, but this time it is z, so z, and additionally z dash. So this 2 and this 2 will cancel. So basically 1 by, what was root z? What was z? Cot x square in square root. Remember, x square is inside cot. Okay, and differentiation of cot x square. Differentiate that. So now first function is cot, leave it. Whatever is present inside, consider that to be your new z. This is my new z now. So copy. Differentiation of cot is minus cosec square z, because that will be z, so z is x square, into z dash. Z dash means differentiation of x square, that is 2x. Okay. 8th, cos root x. I think this is now easy, because the first function is cos, leave it. Whatever is present inside, consider that to be your z. So cos z differentiation is minus sine z into z dash, that means minus sine root x, and root x differentiation. Learn the differentiation of root x, that's 1 by 2 root x. Okay. All right, this is done. Let's look at few more questions based on this. Differentiate this. Okay, the question is still differentiation. Differentiate with respect to x. So e raised to power sine inverse x. Okay, the first function comes is e. Leave it. Whatever is present, consider that to be your z. So that we have to differentiate e raised to power z. What is the differentiation of e raised to power x? Is e raised to power x. Differentiation of e raised to power z will be e raised to power z. And additionally, you'll have z dash. Remember that differentiation of e raised to power x is e raised to power x. Same. So e raised to power z differentiation is also e raised to power z, but additionally z dash. So e raised to power z. Oh no, let's replace z. Sine inverse x, and now comes differentiation of sine inverse x. Okay. Now I'll give you the basics for inverse differentiation, the rules first of all, because that was pretty much not covered. I told you that whatever rules will come, so we'll discuss accordingly. So now some other rules, that sine inverse x differentiation is 1 upon square root of 1 minus x square. Consider that to be as a standard. Then differentiation of tan inverse x is 1 upon 1 plus x square. And differentiation of then comes sec inverse x, that is 1 upon x square root of x square minus 1. Similarly, you have cos inverse x differentiation also. That's not different from these. Learn only these three because this is just negative of it. Means every single result is just negative. Cot inverse x is minus 1 upon 1 plus x square. And cosec inverse x differentiation is 1 upon negative 1 upon x square root of x square minus 1. All right. So now I think we can do this based on these rules. Sine inverse x differentiation is e raised to power sine inverse x upon square root of 1 minus x square. All right. Done. Next, let's take this. E raised to power x cube. Okay, so same idea. First function is e, leave it, x cube. Consider x cube to be your z. So same idea, e raised to power z differentiation, that's e raised to power z into z dash, that's e raised to power x cube, and differentiation of x cube, that's e raised to power x cube into 3x square. Simple enough. Let's complicate things. Sine bracket tan inverse bracket e raised to power minus x. Okay, a lot of things. The first thing comes is sine. Consider everything else to be your z. So what is the differentiation of sine z? Cos z into z dash. So cos bracket, replace your z, tan inverse e raised to power minus x, and then differentiation of z dash. So tan inverse e raised to power minus x differentiation. Okay, that's a sign of differentiation. Now what is the first function that comes in this differentiation? Tan inverse. So leave it, whatever is present inside, consider that to be your new z. Okay, so multiple chain rule. Copy tan z. And now I'll do this directly. Tan inverse z, actually tan inverse z differentiation. What is the differentiation of tan inverse z? 1 upon 1 plus x. Instead of x, now you have z square. Oh, sorry, my 2 and my square matches, so z square into z dash. Okay, so copy, multiply 1 upon, what was z? 1 plus e raised to power minus x whole square into differentiation of e raised to power minus x. Now what is the differentiation of e raised to power minus x? It is close enough with e raised to power x. It's just that instead of x, now you have a coefficient of minus 1. So see, e raised to power x differentiation is e raised to power x. If we use the ax plus b rule, e raised to power ax plus b differentiation will be same, e raised to power ax plus b. Is just that coefficient of x will come in multiplication. If we use this, so what is the differentiation of e raised to power minus x? Same, e raised to power minus x. It's just that minus 1, the coefficient of x will come in multiplication. So copy, copy, and differentiation of this is minus e raised to power minus x. That's your answer. Okay. So use this ax plus b rule. This will come in integration also, and it can be applied in differentiation also. So don't use again chain rule for this. I'm not saying that you cannot do that. It's just that why waste one more step? Okay. All right. Next, let's see log also. Log cos e raised to power x. Multiple functions again. Go in order. What is the first function? Log. Leave it. Whatever is the inside, that's your z. So log z differentiation. What is the differentiation of log x? 1 by x. What is the differentiation of log z? 1 by z into z dash. Additionally, every time we differentiate z, we multiply z dash with it. Okay. So 1 by z here means 1 by cos e raised to power x. Remember, e raised to power x is inside cos, and then differentiation of cos e raised to power x. And again same thing, you have to differentiate this now, cos e raised to power x. So what is the first function? Cos. Leave it. Whatever is present inside, consider that to be our new z. So what is the differentiation of cos z? Sin z means sin e raised to power x, and differentiation of z dash. Additionally z dash means e raised to power x. Okay. All right, done. Okay, next let's see. Okay, look at this. These two questions are okay. Let's look at this. Okay, so square root, e raised to power square root. I told you to learn this differentiation of square root. You can see the significance now. So what is the first thing that came? Is square root. So whatever is present inside, that will be your z. So your question will look like root z dash. Differentiation of root z is 1 by 2 root z into z dash. 1 by 2, z was square root of e raised to power root x. Okay, and then differentiate e raised to power root x. What is the differentiation of e raised to power root x? Again, consider this to be your z. Copy. E raised to power z. Differentiation is e raised to power z only, means e raised to power root x, and differentiation of root x. And what is the differentiation of root x? Directly write down 1 by 2 root x. Okay. Next comes this question, log bracket log x. So inside log another log is there. So leave the first log, take this log as your z. So your question will actually be log z dash. So what is the differentiation of log z? 1 by z into z dash. That means 1 by log x into differentiation of log x. So basically 1 by log x into 1 by x, or 1 by x log x if you want. All right. So that is pretty much about your chain rule. Okay. All right. Okay, so this was all about chain rule. The next subtopic of this chapter we'll do in the next class. Okay, so we still have a lot of forms to cover. Parametric form, multiple derivatives are also there, second order or higher order derivative. So remaining portions still we have to cover. We'll do that in the upcoming classes. Okay, that's it for today. See you in the next class. Good day, everyone.